Okay, so hey everyone. Today I'll be doing the Math Week 4 AMS quiz. So I'll start with the first question. Which of the following defines a function? Select the two options. The way you know if it's a function is by applying the vertical line test. And I explained it in last week's math. No, wait, that was 2 weeks ago or last week. Point is, what you do is if you put a line through one of the grids or draw a vertical line throughout wherever the function passes through or the relation. If it passes through only one point, you do this for all the points, by the way. Passes through only one point, it's a function on all of them. But if in the case if it passes through two, it's not a function, it's a relation. So using what I just said, if you draw a line through each line, whatever these are called here, the axes, grids, I don't really know. You should only pass through one point. Here, as you can see, it passes through 2 points if I just throw my mouse over it. Here, if you can draw a line here, as you can see, it'll pass through 2 points. Here, you draw on this line, it's gonna pass through 2 points, and here as well. And here, only the points, the fact that they only give you a points and not lines makes it much easier for you. Just draw a line over each of these points. You see, it is not a relation, it's a function. So our functions are this one and this one. I say it's not a relation, but all functions are relations. Okay, with the circle below, F is a diameter. Which of the following must be true? Select or multiply. Okay, EF equals 180. Because it's a semicircle. If it's a diameter and it cuts the circle in half. If it's a diameter, if it cuts it in half, half of 360 is 180, and 180 degrees is a semicircle. The measure of a semicircle is 180 degrees. So FE is EF or FE, same thing, equals 180 degrees because it's half of 360, I just explained. And EDF is a right angle because angle D is an inscribed angle and it intercepts arc EF. When an inscribed angle intercepts an arc, it's gonna be half of that arc. So half of 180 is 90. So that makes EDF a right angle. Okay. Question 3. Which of the following functions are even? For this one, I'll go to you. By the way, here I made a mistake in the PDF. I said it's week 3, but it's actually week 4. So ignore this. All the questions are from week 4, and I just wrote week 3 here. So just ignore them. Which of the following functions are even? Select the three options. Okay, an even function is a function that has f of x equal to f of negative x. So what I mean is you take your normal function. So for example, we'll take the first one, which was in my case g of x equals the absolute value of x minus 7. This is what they gave us normally right here. Okay. Uh, so you write down that function and then you compare it by substituting negative x on another line. So it will be the absolute value of negative x minus 7, which is, since it's an absolute value, it will still be x minus 7. So they're equal to each other. Okay. For the next one, h of x is equal to x to the power of 7. Now, h of negative x is equal to negative x to the power of 7. So as you can see here, they're not equal, so this function is not even. Now, if you have an even exponent, so like x squared, x to the power of 4, x to the power of 6, etc., you're gonna find that those are even functions because, negative answers can turn into positive answers with even exponents. So x to the power of 7 is an odd exponent though, so that rule doesn't apply. So x to the power of 7 obviously is not equal to negative x to the power of 7. So this function is not even, which is this one. Okay, now we have f of x is equal to the absolute value of x minus 7. Okay, f of negative x is negative x minus 7. As you can see, this is not the same, so they're not equal. Now, if they give you a harder question, like you're gonna find maybe an absolute value that's uncertain, like you're not gonna be unsure of your answer. I wrote some optional steps. If you have something like this, you can factor out the negative sign and take it out of the absolute value, making it positive, which will make f of negative x the absolute value of x plus 7. Now, x minus 7 an absolute value and x plus 7 aren't the same. So f of x is not the same as f of negative x. Now, I advise you to do this further step if you have this case, or if you can factor out anything in general. And just to be sure of your answer. only if you don't have time, I would say don't do it. Okay, v of x is x squared plus 7. And v of negative x is negative x squared plus 7. So negative x squared is obviously going to be, I made a mistake here, it should be x squared. So let me just open the whiteboard. uh, Stop. This is meant to be x squared plus 7, not x to x plus 7. So those two are the same, so it is an even function. Now I think I only wanted 3, so yeah, okay. U of x is equal to 7. Now constant functions are even. Ignore this. I was thinking of something else. I was scribbling. So those are your three options. The one that has v of x, the one that has u of x, and g of x. So let me just compare. See, u of x, v of x, and g of x. Okay. Which of the following functions are odd? Select two or correct options. Okay. An odd function is a function that has f of negative x equal to negative f of x. No, wait. Let me rephrase this better. Okay. A function is odd if f of negative x is equal to the negative function of x. What I mean by the negative function of f of x, uh, you flip the function basically. So like say you had f of x to be like, let me just draw f of x equals 7x minus 4, for example. Okay. Negative f of x would make it negative 7x plus 4. So it's basically just the opposite function. It's the inverse. And the f of negative x, I just explained it in the even function, so I won't explain it again. Now, w of negative x, let me just look at what w of x is. 2x minus x cubed. Okay, so w of negative x, you're gonna substitute, so you multiply negative x by 2, so making it negative 2x, minus negative x cubed. So you are minus with minus make a positive, so it'll be negative 2x plus x cubed. Okay, which just to confirm is not the same. Yes, it's not the same as the other one. And negative w of x is equal to negative 2x plus x cubed because again it's the inverse. So sorry. Uh, Negative 2x plus x cubed is equal to negative 2x plus x cubed. So this is an odd function. Okay. P of x is equal to x plus 2 squared. This is just a normal function. P of negative x, you substitute negative x here. Uh, Obviously, you would do the negative p of x now. So negative x minus 2 squared. Now, negative x plus 2 squared isn't the same as negative x minus 2 squared. So these two aren't equal functions. These two aren't the same, sorry. So it's not an odd function. Okay. Now, q of negative x is equal to, let me just check if it's, okay, it's negative 2x cubed. So q of negative x is going to be positive 2x cubed. And negative q of x is negative 2x cubed. So these two are obviously the same. My bad here. This is meant to be, there should be a negative symbol here. I don't know, I didn't draw it. There should be a negative symbol here. Yeah, so these two are the same, which makes this an odd function. Okay. Let's go to question 5. Okay. Now, you should know that opposite angles in a cyclic quadrilateral are supplementary. So y plus 74 equals 180. A couple of mental maths, you'll see that 106 is the answer because 74 minus 180 is 106. Okay, now there's a rule here. Question 6. Uh, there's a rule where it says that the exterior angle, so like let's denote this angle as x, for example, and we'll denote this angle as z. Ignore the terrible angle one. Okay, say this is z. Now, z is equal to 118. Basically, what the rule says, the this angle, the supplementary angle, the interior angle, is congruent to the exterior of the opposite interior angle. Or you could say it in another way to say it easier. The exterior angle of a cyclic quadrilateral is congruent to the opposite of the interior angle in the cyclic quadrilateral itself. So z equals 118, and now you just add the values up, subtract them from 180 because it's a triangle. So this is going to be 118. 118 plus 38 minus 180 should give you the value of y, which is 24. Now let me just check here. Look, 118 plus 38, 1 minus 156, 24 degrees. Okay. If one angle of a cyclic quadrilateral measures 55 degrees, then the measure of the opposite angle must be 125 because, again, opposite angles are supplementary. So 180 minus 55 is 125. So that's that answer. Same application, 2x plus 9 plus x is equal to 180. 3x is plus 9 equals to 180. 3x equals 1. Oh, 3x plus 9 equals 180. So 3x equals 171. Divide by 3 on both sides. Where's the question? X equals 57. Okay, I skipped the question. Question 9. Okay. Since the KL is the diameter, M is 90 degrees because again it's half of the arc that it's formed by the semicircle. So this is 90 plus x plus 4x minus 15. So we'll just go here, 90 plus 4x minus 50 plus x plus 4x minus 15. You combine the x's, 90 plus 5x minus 15 equals 180. 90 minus 15 would be 75. So 5x plus 75 equals 180. Take 75 to the other side. 5x equals 105. Now 5 times 20 would be 100. So 20 plus 5 would make it 105. So 21. This is my way of doing log division. So or multiplications. Ignore that. Okay. So the other two questions, one of them is mental math, which is this one. Basically, if two angles intercept the same arc, so this is the arc, as you can see, they're intercepting the same arc. Ignore the terrible drawing. Now if I would draw this with actual straight lines, you would see that they intercept the same arc. Angles that intercept the same arc, basically they're congruent. So 6x plus 6x equals to 48. Divide by 6 on both sides, x equals 8. Which of the following? Which of the following? I'm blind. Okay, I'm sorry. A function defined by the points indicated by dots on the grid below. Which of the following points? Oh, it's here, never mind. If removed, makes the function one to one. If more than one such point exists, enter any of them. Okay. To make a function one to one, instead of applying the vertical line test, you're gonna apply the horizontal line test. Same thing with the vertical line test, except it's horizontal this time. So you draw a you draw a line on each, whatever this is called. I haven't done graphs since grade 7. So as you can see here, it passes through points Q and U. Now, your two answers could either be Q or it could be U. Now, here they answered Q. Let me just check if they accept U. They should. Yeah, okay. It's either Q or U. When defined over the set of real numbers, the function f given by f of x is equal to 4x minus 2 squared minus 5 is not 1 to 1. If the file domain, okay. What you do here, you have something called the quadratic general form. Okay, f of x is equal, or y, f of x is y because y is the range, and what you get of the value when you're done with the function is your range, so they're the same. Is equal to a in brackets x minus h squared plus k. Now to restrict the domain to make it 1 to 1, x can be greater than h or x can be less than h or equal to on both cases. So you can accept both answers. As you can see, x is less than greater than x is less than or equal to k, or x is greater than or equal to k. Now I said here that h here it can be less than or equal to it, or greater than or equal to it. So in this case, our h is 2 because it's already in the quadratic general form. So 2 would be your answer, which is what they put here. Okay. Consider the function g whose domain is the set of all values of x between -4 and 4 inclusive and whose graph is shown below. Let's m be the final set of g and g is on 2. Okay. An onto function. In an onto function, basically all your range values is equal to your final set. Now I defined what each of these are. Your final set is all possible values that can come out. So every set of the function, any set. Now most of the time it's all real numbers, okay? But the range is the values that you actually produce from your domain. So like say you restricted your domain to, like, for example, 5, 10, or and 15. Let's say multiples of 5. I don't know. Okay. Now, if you plug these into any function, let's just ignore. We don't need to write the function. You'll get your range values. But if you put your final set, if you put your domain as every number on in the world, infinite numbers, you'll get your final set. It's all possible values that can come out, which is generally the set of all real numbers. Okay. So your range in the onto functions, your range is equal to your final set. Okay, like each value of your range is mapped onto the final set, or vice versa. Each final set value is mapped onto the range. Okay, so your range obviously is your highest value and your lowest values. It's all values between it. This is our domain. Uh, so you find the highest value on the graph, which is here 1, and your lowest value here, which is -3. 1 and -3. These are the values of A and B. A would be -3 because B is greater than A. They want the value of B, so B is 1. Okay, let me just see if I added any explanation here. Range is equal to the final set. Okay, they want you to find your final set. Now, generally, in most of the times it's real, but I said this like 3 times now. But in some functions where you have a domain really restricted, or something else, you have conditions. It's in the book. I didn't bother reading it. They'll give you either a graph or they'll give you an equation. They'll give you something like an example of a book, which I'll pull up later. Um, I advise you to read that, by the way, because even though it doesn't explain, the example kind of helps. Basically, if you want to find your final set, you need to find your range because those two are equal. Like each range is their final set. Okay. As I explained, now you find your highest and lowest values because that's your range between A and B. Uh, okay, so 1 would be our highest value and -3 would be our lowest. They want the value of B and B is greater than A, so 1's your answer. Okay. Question 15. If it moves on my own, question 14, whatever I'm on. What am I? Okay, question 14. Select the graphs that represent one-to-one functions. Again, one-to-one functions, you do the horizontal line test. I'm not gonna explain it because I just did. But here, just try the two curves they gave you. Everything else, as you can see, it passes through 2 points on a horizontal line. Here though, you can see this one only has 1 point on each one, and this one's just a set of points, so you can do it mentally. You can do all of them mentally, which is what I did. Okay, x plus 55, 3x plus 45. Again, these two intercept the same arc, so they're congruent. X plus 55 is equal to 3x plus 45. You take x to the other side and the 45 to the side of the 55. To x equals 10, x equals 5. Okay, question 16. Which of the following is true? Select the two correct options. Okay. The set of f of x equals to the root of x plus 5 is the set of all real numbers greater than or equal to 5. This is correct because if you put, let's just say, -7, you're gonna get -7 plus 5, which will be root of -2. Root of -2 is undefined because you can't have negative values inside the root. So same with anything else. So you need x plus 5 to be greater than 0, greater than or equal to 0. Take 5 to the other side. X is greater than or equal to -5. So this is your answer. This is incorrect because I just explained if you have like -6, you're not gonna get an invalid answer. And plus, you can have this is wrong in any way because you can have -5 in the answer because -5 plus 5 is 0 and root 0 is just 0. It's still defined. The domain of g of x is equal to x squared minus 8x is the set of all whole numbers. It's not the set of all whole numbers, it's a set of all real numbers. The difference between all whole numbers are like 1, 2, 3, 4, whatever, all the way until like any number. That's a whole number, not a decimal. Again, you know what a whole number is. But real numbers are numbers that can, in a simple way, be represented on a number line. So, for example, 5.7, uh, 9.3 can even represent pi technically on the number line. So pi is accepted. That's the difference. The whole numbers doesn't include that. Okay, so this is wrong. The domain of g of x equals negative x is x squared minus 8x is the set of all real numbers except 8. Why? You don't have any condition that you need to set an undefined value for. This is defined for every single case. Like if you're to put 8, okay, 8 squared minus technically 8 squared, 64 minus 64 0. That's still defined. Like there isn't any condition to make it undefined. The only times it's undefined if let's just say f of we're not gonna write a function. I'll just write f of x here. 1 over f of x, for example. F of x cannot be 0. So then you find your values, or uh, root uh, f of x. Here f of x cannot be, or it has to be greater than 0 or equal to 0. Those are the only two times, at least what we took in grade 10. بصراحة I don't know if there are any other cases where the function needs to have a condition to like make it valid or to make it defined. Okay, question 17. True or false? 133,199 is an example of a relation. Set A does not contain the number 1. And if it's a relation, it has to pair both numbers. That means both of the sets have to have both of the numbers in them, like all of the numbers together. So 3 is in set A and B, 9 is in set A and B, but 1 isn't, so it's false straight away. Okay. This doesn't need explaining. It's the set of all integers between 13 and 19. As you can see, 13, 14, 17, 13. It's unordered, but all the numbers are there. It is the set 13, 14, 15, 16, 17, 18, 19. Yeah, that's correct. Any other thing there is wrong. Question 19. Consider the relation A. I explained this like 2 weeks ago. For it to be a function, you can only have one y value corresponding to your x value. Or that's the point. So you have 12 here already. So A has to be 23, B has to be 16, and C has to be 20. They want A, so A is 23. Okay, question 20. Function w is given by w of x, 4 minus 5x. What's the value of w? Negative 2. Substitute negative 2 into your equation. Wait, what question is this? 20, so I scored a bit too far. Okay, substitute negative 2. So 4 minus 5 times negative 2, which is negative 10. 4 minus negative 10 makes it positive. 4 plus 10 is 14, and 14 is your answer. Okay, root 4 root x minus 1 plus 24. X is greater than 1 or equal to it. What you do here, you substitute your smallest value. I don't have it, it's in here. You substitute the smallest value that they gave you. Like say they told you, they restricted your domain to have it x greater than 2. That's your domain, x greater than 2. Substitute 2.1 or 2 point, well, 2 point, whatever. They're not going to tell you that. Substitute x greater than or equal to 2. Substitute 2 in your x values. So 4 minus 2 minus 1, whatever. Okay. But here they want you to do 1 because it's greater than or equal to 1. So 4 root 1 minus 1, 1 minus 1, 0. 4 root 0 is 0. 4 times 0 is 0. So you're just left with 24 because this became 0. Root 0 is just 0. So 4 times 0 will obviously give you 0. 0 plus 24 uh, equals to 24. Okay. I don't know why my throat's been hurting recently. Okay. The function h is given by h of x root 84 minus 4x, the domain of x. This came in the exam so many times. This is greater than or equal to 0. Your value is 84 minus 4x is greater than or equal to 0. You take out, you take them out of the root, take 84 to the other side. Negative 84 is greater than or is less than or equal to negative 4x. Divide by negative 4x to isolate x on both sides. X is less than or equal to 21. So and that's your answer. I'm sorry if I'm rushing through these, by the way. Okay. Given f of x minus 1 over 2x minus 50, over 2x plus 10, uh, you find the value that makes this undefined. So 2x minus 50 cannot be 0, 2x cannot be 50, x cannot be 25, because it's in the denominator, they cannot be 0. Same thing for this one, x plus 10 cannot be 0, x cannot be negative 10. Okay. X minus 10, x squared minus 22, x plus 40. So here, x squared minus 22, x is 40. You factor to find your two values that aren't going to be equal to 0. X minus 20 cannot be 0 and x minus 2 cannot be 0. So x cannot be 20 and x cannot be 2. Question 25. What's the value of f of same thing? You substitute negative 5 and your x values. Negative 5 times negative 5 squared minus 4 times negative 5 plus 9. Negative 5 squared is 25. And 4 negative 4 times negative 5 is going to be positive 20 because negative times negative make a positive. Plus 9. Now to combine 20 plus 9, you're going to multiply 25 by negative 5. Negative 125 plus 29, negative 96. I'm going through these quickly because it's been in the exam so many times. We don't need this. We don't need to do them again. Okay. So here you have your set. So I wouldn't denote them as A, B, and C. I would denote them as tennis or T, B for basketball, and F for football. Then in brackets, write A and B and C just to not confuse you for the last part, which is what I did here. Now, for the first question, they asked us how many students play tennis, if I remember correctly. Yes, okay. Now you want only tennis, so you want to only include the values in the circle itself, not intersecting with any other circles. So you want only the values that are above this line, which is 9 only. So our answer is 9. And now they want us to find the number of students who play basketball, which is 22. I'm not gonna use this one because the set I drew because this I'll use it for part C. Okay. So basketball would be B, so it would be 10 plus 7 plus 2 plus 3. 7 plus 3 is 10, plus 2 is 12, 12 plus 10 is 22. It's the number that's basically included in all of these sets added together. So like, because this is its own set. So if I just draw it here, ignore whatever left is, ignore whatever's here. You can see it's 7 plus 2 plus 3 plus 10. So you add all these up together to find how many students play basketball. Now, not only basketball, everyone who plays basketball in general, because not 10 is the people who play only basketball, 7 is basketball and tennis, 2 is who plays everything, 3 is basketball and football. Okay, so we added them, we got 22, right? Okay. Now they want the number of students in A intersection B union C. Okay, A intersection B union C. B union C is all of this, all of what I drew the lines on. Now the intersection are these values, the values in the middle. So let's go here in the quiz so I can get a better view. It's these values here. Uh, because it's intersecting with the union. So it's gonna be 7 plus 2 plus 3. Plus 2, sorry. 7 plus 2 plus 2. 7 plus 2 would be 9, plus 2 would be 11. or 7 plus 4, you can add up the 2's first. وبتطلع معك 7 plus 4, which would be 7, which is equals to 11, and that's your final answer. Okay, this was the week 4 quiz. Hopefully, physics would be either out by today or by tomorrow. The periodic for chapter 7. I'll do the chapter 7 quiz. Hala's supposed to be doing the chapter 8 quiz. Allah يعلم. So, yeah, good luck, guys. Uh, see you in the next video if I do physics today. يلا باي باي.